Okay, so welcome back. This is recording 2 in Unit 4, the periodic table. And in this recording, we'll be discussing periodic trends, metallic character, atomic radius, ionization energy, and electronegativity. And this is a super interesting part of our discussion, and it's a nice lead-in to our next unit, Unit 5, which is chemical bonding. And let's start with the metallic character trend. And it says here, as you progress across a period, metallic character decreases. As you progress down a group, metallic character increases. And this makes sense because if we look at our table here, and if you go across periods, you'll notice that you're going from the metal side of the periodic table to the non-metal side. In our previous recording, we said that this stair-step line here divides metals and non-metals. And so on the left-hand side of the stair-step line, you have metals, and on the right-hand side, you have non-metals. So as you move this way, you're going more toward the non-metal side of the table. And as you move down a group, the atom gets larger and larger. We'll talk about that in the next trend. And the electrons are more easily shared. And that is a characteristic of metals, not shared but transferred. So as you move down, the electrons get further away and they can be pulled off more easily. And that's a metallic character, is losing electrons. So you can kind of look at it that way as well. And this property of losing electrons is determined to a great extent by atomic radius. The definition differs somewhat between sources, but in general we say it's the distance from the nucleus to the outermost electron. We will say that this trend for atomic radius increases as you go down a group and decreases as you go across a period. So let's talk about going down a group first, and then we'll talk about the period trend next. So as you go down a group here, or a family, the atomic radius increases. And that is because that as you move down groups, you get bigger, larger and larger shells or energy levels. The size of the electron cloud, the shell gets progressively bigger as you go down. Remember when we talked about principal energy levels being the size of the electron cloud. And so as you go down the group, or as you go down the family, the size of the shells gets larger and larger, and so the electrons get further and further away from the nucleus. So as you go across a period, the shell size stays the same, but the number of protons increases. You get more and more electrons as well, but the proton kind of dictates the size of the atom in the same size shell. So if you have a really strong nucleus with lots of protons, it's going to pull that shell in and make the atom smaller. So as you go across a period here, the size of the atom gets smaller and smaller. All the other trends are opposite of atomic radius. They're linked, but they're opposite, and we'll talk about that as we go along as well. And the first one we're going to talk about is ionization energy. And ionization energy is the energy required to move an electron. And so they talk about first ionization energy and second ionization energy. The first ionization energy is the energy required to remove one electron. It's usually from that outer shell. So the energy required to remove an electron from that should read an atom there instead of an ion. Okay. It says here, first ionization energy is the energy required to remove the first electron from an atom. Second ionization energy is the energy required to remove the second electron. Okay, so let's talk about the general trend here. It says the trend for ionization energy is to increase as you go across a period and decrease as you go down a group. The reason is that going across a group, there is an increase in the number of electrons within the same shell, so the proton can be pulled, can pull the electron closer. So here, this should say across a period. So cross that out and write period down. In fact, I'm going to do that for you. It'll let me. Okay, so as you go across a period, on the periodic table like this, it increases. And as you go down a family or a group, it decreases. And let's talk about that for a minute. As you go across this period, it increases because the size of the atom gets smaller and smaller. And so what happens is, as the atom gets smaller and smaller, it gets harder and harder to remove that electron because you're getting closer and closer to the nucleus. Let's do it with this fist. Okay, this is the nucleus. So you get closer and closer to the nucleus, and this nucleus pulls harder on those electrons. So the amount of ionization energy to remove that electron goes up. Okay. As you go down a period, the atom gets larger and larger and larger, right? And so as the atom gets larger and larger and larger, the electrons get further away from the nucleus. And so therefore, they're easier to remove, and that ionization energy decreases. The energy to remove that electron decreases because the electrons are further and further away from the nucleus. So going down a group, the electrons are getting further away from the nucleus with increased number of shells and shielding electrons. Therefore, the protons cannot exert a great attraction for that electron. And so this leads to an easier removal of those electrons from the shell. So the ionization energy decreases as you go down. Although ionization energy generally increases as you go across a period between group 2 and 13 and 15 and 16, the energy decreases because of the increased energy it takes to remove electrons from the full S and the half full P subshell. So here, as you go across a period, it should read, as you go across a period between groups 2 and 13 and 15 and 16, the energy decreases because of the increased energy it takes to remove an electron from the full S and the full P subshell. So I'll explain that here like so. Okay. So here you have a full S subshell, right here with this element that's in group 2. And so to remove this electron is extremely difficult, but this next electron in group 13 takes a little less energy, so you get a slight dip in energy there. The same thing is true between 15 and 16 here, because you have a half full P subshell. Remember, this is the P, right? So I got P1, P2, P3. And so to remove this electron takes a lot more energy than to remove the next electron in the sequence. It's a little bit of a dip. But in general, the trend is to increase as you go across and decrease as you go down. And depending on your teacher, they may or may not quiz you on that kind of a refined concept. Okay, let's go on. Electronegativity is the attractive force that an atom or an element has for a shared pair of electrons. The number is usually between 1 and 4, well, it's always between 1 and 4. And the higher the number, the greater the affinity for the electron. The general trend is for electronegativity to increase across a period and decrease down a group. And so nonmetals tend to gain electrons and metals tend to lose electrons. And so the ones with greatest electronegativity would be up here. Group 18 doesn't have electronegativities because they have a full outer shell, so they don't want to gain an electron. But for example, chlorine and fluorine have high electronegativities because they want to gain an electron. Non-metals gain electrons and become negatively charged. Metals like to lose electrons, and so the ones with the lowest electronegativity would be down here, and they want to lose electrons. And so this difference in electronegativity is something that we'll use in the next unit to talk about chemical bonding and the patterns of bonding, whether when two elements get together, if one will lose an electron and one will gain an electron, or if the electrons will be shared between atoms. And if they're going to be shared between atoms, how well are they sharing them? Are they sharing them equally or unequally? And so this trend in electronegativity is super important in chemical bonding. Okay, so this concludes our discussion of the periodic table and periodic trends. I hope you've really enjoyed this unit, and do your study questions and get ready for Unit 5, which is chemical bonding. Super exciting, and we will talk to you then.